Last one, here we go. Example 6, question 2. I'm trying to see if these two sides are equal or not. This is actually a very common mistake that people make in algebra. Saying that something like x minus 3 squared is the same thing as x squared minus 3 squared. And we know for a fact this is false. So let's prove it using trig. So on the right side, we have this thing we can FOIL out, right? So let's write it out so we can see exactly what we're multiplying together. So sine theta minus cosine theta times sine theta minus cosine theta. So this is my left-hand side. And I'm going to multiply my binomials together, so that gives me sine squared theta minus sine theta cosine theta minus another sine theta cosine theta. And then finally at the end, a plus cosine squared theta. Okay, let's combine what we can. So sine squared theta minus 2 of these, 2 sine theta cosine theta, plus cosine squared theta. That is not equal to sine squared theta minus cosine squared theta, and there's no way to make it equal. You could try substituting in some Pythagorean identities and tweaking it and see if you'll come up with something that matches, and it's not going to work. Okay, let's look at this other method, plugging in an actual value. I talked about this on the last one. Make sure you don't choose a 45-degree reference angle or a quadrantal angle, because you could get some anomalies from the fact that sine and cosine would be the same, and that the 90 degree sines and cosines are 1s and 0s, and that can always change things so you can't see what's really happening. So again, if we choose about 30 degrees, that's good. This side of our problem actually is exactly like part 1. So we get this 4 minus 2 square root 3 that we had earlier by plugging in sine 30, cosine 30. Subtract those, combine them together, multiply the numerator, simplify, etc. But the other side of our equation will have sine 30 squared minus cosine 30 squared. So 1/2 squared, which is 1/4, and square root of 3 over 2 squared, which is 3/4. Subtract those, we get negative 2/4, or negative 1/2. Well, I know we figured out earlier that this was like 0.13 something, right? This we know is negative 0.5. Those are completely different answers. So therefore, this does not work. They are not equivalent. And hopefully that helps you understand a little better why it's so important that we actually FOIL this out. You know, maybe write it out so you don't forget those inside-outside terms. That it's not just squaring this and squaring this. It's a lot more complicated than that, because the x minus 3 is connected together. And so you can't just split it up like this. All right. In conclusion, here's some strategies. We've seen a lot of these today. Try working on the more complicated side first. We can use our quotient and reciprocal identities, maybe make everything in terms of sine and cosine, or at least in terms of what the ratios are on the other side. We might add fractions together, right? Make sure we get common denominators before we add them together. So if this were, I mean, we would learn this in Math 1050. Rational expressions are those fraction ones, right? Use Pythagorean identities to exchange sines, cosines, tangents, and secants, cotangents, and cosecants. Simplify sums or differences of squares to one term. So Pythagorean identities. Multiply by a conjugate so that we turn it into a piece of a Pythagorean identity. We've also multiplied the numerator and the denominator by other things to get them to match what we're looking for, right? If you find yourself stuck working with one side of the identity, try starting with the other side of the identity and see if you can find a way to bridge the two parts of your work. All right, good luck. You've got